Good afternoon. I'm Amy Caruso. I'm the head of collateral initiatives at ISDA. There's a lot of friendly faces, but just in case anyone's not familiar, ISDA is the International Swap and Dealers Association, and I work on a very important topic, collateral. Now, due to financial regulations over the past few years, collateral management is critical to the resiliency in our financial markets. And that sounds like a pretty big statement. Sounds pretty bold from a girl from Western Massachusetts to state. But let me just put it in perspective. Based on just the ISDA, so just derivatives, swaps, and cleared derivative transactions, there's about $2 trillion. With a T, $2 trillion on an annual basis that is moved in collateral every year, or at least in the past year as of the end of 2022. So that's initial margin, variation margin for both uncleared and cleared products. And as I mentioned, that's only related to our products, but we are collaborators. So we have SEC lending, repo, TBAs, and exchange-traded products as well. So it's much beyond that $2 trillion. Now, with each product and each trade, there's documents, there's processes that unfortunately have become quite complicated over the years because everyone thinks their way is the best way. Their documents are the best documents. But there are actually many commonalities, many similarities, even among the different types of collateralized products. So, oh, don't be shy, come on in. Oh, we met before, yeah, excellent. So all of these leads to great opportunity for the common domain model to standardize financial products, the trades in those products, and in our case, a post-trade event, collateral management. Now, my collateral initiatives colleagues at ISDA, Vernon Alden Smith, will kick us off. And then we also have another collateral collaborator. I'm going to term that for us, Tom Healey from ICMA, the International Capital Markets Association. And if what they share with you in the theme of art of possibility with the common domain model piques your interest, there's another presentation right afterwards that will be about ISDA SIM, and they are colleagues and another collaborator in the back from the International Securities Lending Association, Chris Rayner. They will all be at the booth or the table, which is in the far corner. So don't be shy, stop by this afternoon because we have a lot packed in for 30 minutes. So you two ready? Yep. All right, Vernon, you're up next.
Oh,
Let's
sorry.
not trip going into this. That would be,
Hi, everybody. Hopefully you can hear me okay. So today I'm going to take you on a journey of evolution of one of our areas of collateral management we developed in the common domain model, or CDM as some of you know it as. So, you know, the data model, we've been able to develop data standards as open source for the industry to use to kind of bring efficiency and interoperability to different processes that happen in collateral management today. Now, we've developed many areas. Today, we're going to focus on eligible collateral representation, but there are other areas such as collateral documentation, margin call data, collateral balances, etc., that are also in the data model. But we're going to focus on this today. And, you know, what we're going to do is break it up by some slides, me talking, make it a bit more fun. We've got a video with an electronic computerized voice, which will be quite good. That's 7 minutes long. That's going to kind of bring this to life and show you a demo. And then we're going to hand over to Tom Healey, who's going to take us through another use case in the repo market using CDM, eligible collateral representation. So, the common problem really is all these industry players, custodians, broker-dealers, buy-side vendors, they all represent collateral assets in different ways. But really, they're talking about the same thing. So, what the CDM can bring us is standardization of common language and data that's structured to be able to put the information together and bring the, you know, fewer reconciliations, improve onboarding, mitigate disputes, and all the end-to-end things that happen through the collateral process. I think certainly in the derivatives market, there's been a lot of change, regulatory change, that has impacted volumes of margin calls significantly, and more negotiations and new documentation that all have eligible collateral lists within them. And what these eligible collateral lists are lists of assets that you can exchange between one another to mitigate counterparty risk if things go wrong. So I think we'd all agree that there is a need and there's an opportunity in the CDM to build some standards to help in this area and bring us into operability. So, I mean, with ISDA, we have a large membership and also ICMA and ISLA. All our members come together on our working groups to identify what the requirements are, and we've been working on this for several years. So in the industry, we see many different representations of eligible collateral data. There's some examples here. There's free format tables that's in documentation that encourage people to put in their own terminology. You have different taxonomies that are used, and you also have other formats, such as custodian schedules that, again, use their own data representation. So really, it's creating its own problem. And obviously, as I said before, regulatory change has increased volumes, more negotiations, so there's more need for standard data. So how did we do this? We needed to identify what the requirements are in the CDM. What do we need? We need a standard common way of representing different collateral asset types, different issuers of collateral, and different flavours of those. So securities can be debt or equities, as listed here, funds, warrant certificates. So there's many different forms. Obviously, cash is fairly straightforward, cash in a issued currency, but you know, the CDM model needs different layers of granularity to identify all the different characteristics that are required. But we also need to have the flexibility to use ISINs and QSIPs to identify, you know, asset types and those related taxonomies. The common domain model can also give us a standard way of representing valuation haircuts and treatments, agency ratings, maturity profiles, and concentration limits in different ways, such as percentage or value. So this kind of summarises the CDM, gives us the benefit of a data structure that lays out a standard way of representing all this information, moving away from free format world where everyone's kind of used their own terminology, and gives us a data standard that can be produced as machine readable code to be consumed by computers in processes through the collateral management ecosystem. Bringing this all together, the CDM model can give us a common way of data representation of asset types, whether it's cash, equity, debt, etc. Issuer types of collaterals, whether they're government bonds, corporate bonds, and their agency ratings, etc. And also treatment, such as valuation percentages, concentration limits, and inclusion and exclusion conditions as well. So a combination of all these data standards can be used across many industry areas, such as OTC derivatives, securities lending, repo, cleared, and exchange traded, because they all need to represent collateral assets in a similar way. So this potentially could solve problems for global banks, custodians, data providers, vendors, and connecting solutions, so they can all talk to each other using the same common language. But also, more importantly, having data standards can allow DLT technology to flourish and be built upon data standards, smart contracts, and other technology to add further efficiencies to processes. So we actually can take that further, and we, having a data structure in the model to allow us to represent all this information, we can also, and we've built a user interface to allow industry members and partners to build eligible collateral schedule information using drop-down functionality that can create a table format. So that's quite common in a lot of collateral documents. And it also has the ability to produce data output in a JSON format of a data file. There's a couple of examples here on this slide. It also allows you to ingest CDM JSON data files into the object builder. And within the tool, you can adapt, add, remove asset types, and adjust things and reproduce them. So that's quite good if you have like a standard profile that you want to change time and time again. So there's a number of use cases that the object builder can offer, and this is available as open source on the FINOS CDM page, and it's available as code that people can download. build into systems and adapt it if they need to, and the user interface is all available for people to use and test. Now, we wanted to take this further again and add functionality. So it's great having all this standard data, but what can we do with it and how can it be used? So we did a FINOS hackathon. We took part in May this year. And really the objective was to try and build a tool or a function in the CDM that can check eligibility details. So use an eligible collateral list, but present that with a set of questions to say, if I have these set of assets, are they eligible according to this list? And the function would run that and then tell you what was eligible and then tell you the haircuts. So obviously in a hackathon situation, you've got limited time, but we was able to build this tool and test it. So through the success of that, we wanted to continue to develop it. So we have actually developed the function in the CDM. It's going to be released to the model fairly soon. With a little bit more than what we did in the hackathon. And we're hoping that it can be used and built upon from here. And Tom Healey is going to actually talk about a use case using that function as well. So I think now's probably the best time to transition to the video. So that's the end of the slide presentation. Because we're on quite a tight time schedule, we're going to take questions hopefully in the booths. We're out there. At the end on the left, we've got a CDM table. There's a few of us here who can answer questions on this and take you through it. But I think we are limited on time unless we have a couple of minutes at the end. Okay, I'll now transition to the video. Bear with me. And this will give me a rest from speaking as well. Hang on. We might have a sound problem. Let's just test it.
This demo shows you the common domain model's collateral representation, the object builder used to construct it, and finally, the function to check eligibility. The CDM data model structure for representing eligible collateral starts at the root data type called eligible collateral specification. This contains the attributes to define criteria and means to provide an identifier. Focusing on criteria expands to give you further options to specify the characteristics of the asset, its issuer, and any treatment rules. For asset criteria, we can define the asset type as security and the security type as debt. For the issuer criteria, we can define the issuer type as sovereign central bank. To apply a maturity profile, we use the asset criteria data type and attribute maturity range. The lower bound and upper bound specify the period range. For examples from 1 year to 5 years maturity. To apply collateral treatment rules, we use the collateral treatment data type under eligible collateral criteria. This allows us to apply firstly, the eligibility rule, using the is included option to specify if the criteria is eligible or not. In addition, you can add various valuation percentages, such as haircut percentages, using the valuation treatment data type. Beyond this example, there are many other data options and arrays. These define all the various characteristics of collateral required for use cases seen across industry examples. Users can further explore this using the CDM modeling tools such as the graphical navigator and textual browser. The object builder is a user interface that allows the user to create CDM collateral information using drop-down functions. They can create, import, share or inspect in CDM JSON and view it in a table. The creation of a JSON CDM file is a requirement of the use case for the function to check against a set of eligible collateral details. The JSON files created contain data characteristics related to the asset and issuer, eligibility specifics, including valuation haircuts. We can now show you how the Object Builder is used to do this. The Object Builder starts from all the root data types in the CDM model. Therefore, to start you must select the eligible collateral specification root type here. Then using the plus symbol you open the available data types, starting with criteria. Use the plus symbol to expand, and start to populate starting with treatment, is included, true. This indicates that further criteria you provide are eligible information. We can then build our asset details by selecting criteria, asset, collateral asset type, and then security. You can then add in more details such as the security type, by adding to the collateral asset type, security type, debt. Then add more if needed such as asset, asset country of origin, EU. For issuer criteria, select criteria, issuer, issuer type, and select sovereign central bank. We now have the higher level details of the asset and issuer set. We can now look at adding additional details such as a maturity profile by going back to the asset and selecting maturity range. Lower bound, period, 1 year, inclusive true. Then maturity range, upper bound, period, 5 years, inclusive, true. Finally, if applicable you can include a valuation haircut. This is a requirement for our use case. Use treatment, add valuation treatment, haircut percentage, expressed as a decimal based on the number 1, so a 2% haircut would be 0.02. For our use case example, you now have all the data populated, but as you can likely see the CDM model has lots of optionality to express further details and additional collateral types and their characteristics. You can visualize your CDM eligible collateral schedule in a table by using the viewer or as JSON. To save your data file, go back to the builder and press export. This will pop up and can be saved to your folder of choice for reuse. The CDM contains functionality that, given a query containing asset and issuer details and an eligible collateral specification, can determine if the collateral meets the eligibility and can be used or posted for delivery. The inputs to the function are a specification, like the one we built using the Object Builder earlier, and a query containing the asset and issuer details. The output of the function is an eligibility result that contains the matching criteria. The eligibility query is made up of the maturity, collateral asset type, asset country of origin, denominated currency, agency rating, issuer type and issuer name. The query attributes are optional and can be used in any combination. The function will apply the query to the specification and find the matching criteria, and then construct the eligibility result. The JSON file we created in the Object Builder can be used to execute and test the function. The executable code is distributed for users to embed into their systems. We can use the Rosetta application to execute the function, querying to see if, for example, a 4-year EU debt security is eligible against the specification. The result shows that the query is eligible for delivery of the collateral, and shows the matching criteria, including the haircut percentage. This concludes the demonstration. Thank you.
Okay, let's turn that off now.
Everybody knows what I like to listen to.
Yeah, so just to highlight before I hand over to Tom, the Object Builder is, it's not just for this use case. It can be used across the whole common domain model on any data root type. So it can be explored for other use cases across the entire CDM, such as products, legal documentation, and other things. And the function that we built is quite a, it's the building blocks for something that can be expanded further. I mean, Tom's now going to go on and show us how it can be applied to the repo trades. So, Tom, I'll hand over to you. Do you need to switch leads? Yeah.
Sorry about that. Well, great. Good afternoon, everyone. My name is Tom Healey. I am with the ICMA, the International Capital Market Association. We are one of the 3 trade associations that's responsible for the design and development of the common domain model. It was recently moved onto FINOS, and we've been expanding the product quite a bit in terms of what the model is. We have a lot more participants now that are contributing to the model, many of the major financial institutions. And ICMA itself has about 600 members, so pretty much all the financial institutions around the world. Our primary role, sorry about that. Should put my glasses on. Sorry. So our primary role in the with the CDM is regarding repo and bonds. We added repo lifecycle events into the common domain model, which covers things like repricing, transfers, interest payments, pay downs, substitutions, and so on. So it covers all the lifecycle events that go on in the repo space. What we're covering today and what we're doing is really just showing how the associations collaborate. The work that Vernon and ISDA did in terms of building out collateral eligibility criteria and the test cases. I'm going to just talk a little bit about collateral in the repo space and then do a quick demo of how we use it in an application. Collateral in the repo space, like all markets, can be very problematic. The big issues come down to knowing what you have, knowing where you have it, and knowing whether you can actually get access to it. So what that means is there's a number of research studies that have been done to really identify what the problems are in the space. Inconsistency of the eligibility rules, even though most of the time they're written in legal language, so it makes it difficult for interpretation of exactly which securities you can use. There's inconsistencies in classification, so securities that are eligible under certain European regulations may not apply in the US. So there's issues with regional jurisdictions. There's questions of custody in terms of where the securities are actually being held and whether you can actually get access to it. So knowing where a security is and whether you can use it. Settlement times and cutoff times are a big issue. You may have securities sitting somewhere with a custodian in Asia, and it's inconsistent as to what time what's the end of day in terms of your ability to get access to it, to actually use it, let's say, in an account in Europe. And then there's delivery times, which is one of the big issues. You know it's there, you request it, but effectively you can't really consider it being used until you actually receive it. So there's all these issues really just around kind of knowing where it is and how to get it. And then the reference data. So ultimately you may have a schema that defines what your collateral is, which is all great, but then the data that actually populates those schemas, which comes from many different vendors, is all in many ways defined by the vendor. So there's a mapping and reference data problem. So how does the CDM itself actually help solve this problem? Well, one is that it reduces the inconsistency of the rules. As Vernon had demonstrated, there is a defined set of rules that will be added into the system. Parties agree that what those rules are. The rules are in a machine-readable, executable format, so it resolves or eliminates a lot of the interpretation issues. The classification issue. There's a lot of different taxonomies around classification. Everyone tries to do one, but everyone kind of falls short. When you create a product in the CDM, it is structurally defined. It has the data itself is based on defined values like enumerations and so on. So there eliminates the inconsistencies that can occur. You can synchronize operations across markets. That takes place because it has the embedded eligibility rules. It doesn't really matter when you run it or who runs it. It all is going to be based on the same set of rules at the same time. And then there's adoption. So this is really one of the big things. CDM is an open source product. Anyone can use it, so they can use it in a very somewhat micro way. You don't necessarily have to, and you wouldn't recommend replacing a system for it, but you can actually use it and drop it into systems, into even Excel spreadsheets. You can use interfaces for that. So there's lots of different ways of actually using the CDM across many different platforms. And being open source just makes it easier to use. So just touching upon this ability of the CDM. CDM is not just a model. There's a lot of models that have been developed, but the CDM actually produces executable code. You can get Java code, you can get Python code, you can get TypeScript, you can get a lot of different, but let's say in Java probably primarily. So the model itself can generate objects in many different languages, and then you can embed those objects into many different applications. And so effectively, if you think about it, all of these applications have some model, or actually each one of them in many cases would have multiple models of financial products embedded in them, right? And what this does is it eliminates those models that sit inside the systems and brings them out into one consistent model, which is in the CDM. And then you simply are interfaced. So a lot of the business code and so on that goes into defining the model and interfacing with the model is eliminated. So what I wanted to just give an example of working with Vernon and so on, extending the work that he has done on collateral. I'm going to demonstrate a little bit, or talk a little bit about how it applies for a repo general collateral basket. If you're not familiar with a repo general collateral basket, it's where two parties agree on a general class or list of securities that actually are going to be traded. They generally are traded around the same repo rate. They can be substituted for one another. So a dealer and a client would just agree on a particular basket definition, and then they will deliver. The seller is the one that's responsible for delivering the securities, usually within an hour or at least by the end of the day. It's the seller's choice. Seller decides exactly which securities they want to deliver. The basket definitions are done by many of the different platforms, clearing agents, execution platforms, even dealers themselves have their own definition of baskets. And many of them would be defined in sometimes a term sheet or something between two counterparties. And then the baskets also can be defined on the fly. Could be just a dealer talking to another dealer and says, I'll take any treasuries you have up to 2 years, kind of thing, right? And then on some platforms and baskets, they are split into individual trades. So the baskets themselves ultimately get all broken down into actual trades themselves. So this is just a different kind of representation, UML version of kind of what Vernon was showing from the Rosetta model. Everything kind of stems from this product area, the product definition area. That's really where you think of the CDM, it's pretty much product definition and trade definition. And so this is in the product area. If you go down the tree, if you go across the top, you'll see we define a basket out of a product, right, and put an identifier on it. We go down down the tree to the economics, and then you'll see what Vernon was showing about the eligibility criteria. That's attached to the basket itself. Then going down a little bit deeper. So in this particular case for a GC basket, we have an identifier. We have the securities that will be accepted, which are from the European Investment Bank. They are all AAA rated. I could have multiple rating agencies here. So this is, the representation of what something you would do with like the object builder, right? Going on the asset, so there was the issuer side and then there's the asset side. On the asset side, we look at this being a plain vanilla debt security denominated in euros. The maturity range will be 3 months to 10 years. Again, all AAA rated bonds that would be delivered. Okay? So as you saw from some of the slides that Vernon was showing, one of the representations of the CDM is to output the object structure in a serialized format. In this particular case, it would be a JSON structure. The purpose of doing that is for interoperability. You can take a JSON structure, you can send it over to somebody else that's using the CDM, and they can instantiate it into an object. And so what this does is essentially what Vernon was explaining in his use case. So we're just getting a little short on time. So I will also recommend, if you are a little more technical and would like to see how to use the CDM inside an application, if you just stop over to our table over there. But I will take one more minute if I can and show you the demo that we've prepared. So what Vernon was showing you was using the object builder, right, which is a tool that you can use to do it. What I have here is essentially an object builder, but it's built in a Java application. But all of this is running with the embedded CDM in it. So you can come here, you basically can select your criteria. You can create an object, which would be this object up here, which essentially is that eligibility criteria. It actually looks like this when you create it. So this is the JSON output of that serialized Java structure, right? So it's in a shareable, it's in a format that you can actually distribute and share. In terms of actually using, I will just switch over here. So this is a demo screen that we use that we can do a lot of different types of repo trades and repo lifecycle events with. I'm just changing the security that I'm using to a general collateral basket. You can see over there on the right side, it actually will show the details of what's in the basket, right? So now I have a product object. I have many product objects. Sorry if I go down here. So I have a blotter of positions down on the bottom. Those actually are instantiated CDM product objects. They represent the actual bonds. And the criteria, which is that separate object. So now I actually running that function that you saw Vernon demo in, which will check the eligibility. So now I'm calling a function that's built in the CDM, and it checks the eligibility of the bonds, and then the application simply highlights all the matches. So, sorry, I ran a little bit over. We were a little bit late, but if you, again, want to see how to embed the CDM inside your application, please stop by our table over here. Thank you.